My name is Namiko Saito, and I will present a work on wiping 3D objects using deep learning model based on image, force, and joint information. There are many things to wipe in daily lives. It is important to recognize the shape of the target objects and plan the wiping motion trajectories according to that. In previous research, many of them are limited to wipe only flat tables, or some research which can wipe 3D objects need pre-designed computational models. To the best of our knowledge, our work is the first study that enables robots to trace various unknown 3D shape objects by only learning sensory motor information. To wipe 3D objects, the robot needs to consider the way to wipe according to the shape. For example, if the target is round shape, it is better to wipe continuously. On the other hand, if the target is squared shape, it needs to change the angle by 90 degrees and wipe each surface. Of course, the direction of the wiping motions need to be changed according to the inclination of the surfaces. With our model, the robot enables to consider the way to wipe, and the model does not require a pre-designed model of target objects, and the robot can handle unknown objects. The method is as follows. At first, we collect the image, force, and joint data by direct teach. Second, we train the collected data by neural network model. Finally, we evaluate whether the robot can wipe untrained objects. In addition, we check the role of image and force information in wiping task. This is the experiment setup. We use camera image data, tactile sensor data, and arm joint angle data. We trained 4 objects and evaluated with 4 test objects. When we collect data, we adopted direct teach and replay method in order not to mix the effect by robot itself and experimenter's assistance. We defined the rule as if the tactile force is attached more than 0.1 Newton, the robot succeeded in wiping. This is a learning model we refer our past study. The model comprises 2 modules. Convolutional autoencoder extracts image features, and multiple timescale recurrent neural networks recognize the shape of the objects and generate suitable wipe actions according to the real-time sensor motor feedback. From this slide, I will show the results of the evaluation experiment. This is a movie of a robot wiping test objects. The robot could generate motions according to the shape. Especially with untrained object 1, the robot could wipe every surface with switchbacks. The tactile sensor data shows that there are 3 peaks according to each surface. Unfortunately, when the robot wiped untrained object 2, which has a triangular shape, the robot only touched the top of the object and failed in wiping the upper surface. However, every other surface was successfully wiped. The robot could wipe object 3 with a switchback in the first half and with series of smooth movement in the second half. That is, mixing the way to wipe cube and ball. And with untrained object 4, the robot could wipe it smoothly in a series of actions as a ball. We analyzed the latent space of the model to check if the robot could recognize the objects or not. We plotted circle point when the robot dealt with trained objects. As can be seen, the plots are self-organized according to the shape of the objects. In addition, we plotted stir points when the robot dealt with test objects. From the position of them, we can assume that the robot recognized the untrained object 1 as big cube, 2 as small cube, and 3 and 4 as big ball. We also trained the model changing the input data. When the input was only image and joint information, it was difficult to measure distance from surface and failed in wiping. On the other hand, when the input was only force and joint, the model was overtrained, and the robot could not recognize the shape and wipe them at all. Therefore, we can say that both image and force information are important to recognize the shape and wipe the 3D objects. Thank you very much for watching.